At the end of lesson 5, we ended with a stub page for creating new users. Let's take a look at that. Here's the sample application, and if we go to sign up now, we see that there's this stub. Over the next 4 lessons, we're going to fulfill the promise implicit in this stub. In particular, we're going to create a working sign-up form, as mocked up here. And we'll also allow users to sign in and sign out. And finally, in lesson 9, we'll add authorization to implement a security model for our site. As a first step, though, we need to create a way to model the data that we're going to be storing for our application. And in this case, we're going to be modeling users. Now, you might wonder why we can't build this sign-up form right now. And the answer is that we could, but it's actually a lot easier to build this form once we have already got the data model. Moreover, when you click on this Create My Account button, nothing will happen unless you have a way to persist the data from page request to page request. Solving that problem is the principal goal of this lesson. It's worth noting that there are several off-the-shelf systems in Rails that create a user model and implement an authorization and authentication framework. I think it's important, at least at first, to build your own authentication system. And the main reason is that the off-the-shelf systems are really black boxes, at least until you have quite a lot of experience with Rails development. Most web applications require extensive customization in their authentication systems, which is one reason why you might want to build your own. Moreover, even if you do end up using something that's off the shelf, if you've already built the system yourself, then you'll be in a much better position to understand it and modify it. Finally, I'd like to note that as of Rails 3.1, there's a new method called hasSecurePassword that makes it exceptionally easy to roll your own authentication system. And that's the course we'll be following in this lesson. Let's get started by creating a branch for modeling users. We'll start by creating an initial version of the data model. This isn't the complete data model, but it's enough to get started. You may recall that we did something similar to this in the second lesson on the demo application. Here for the full sample application, I've just added a couple of columns that are added automatically by Rails, and in addition to the ones that we talked about before. Here we've got ID, which comes automatically, name and email, which we're about to define, and then created at and updated at, which are so-called magic columns that we'll be talking about later in this lesson. You may recall that we generated the users controller in the last lesson, and before that we generated the static pages controller using Rails generate controller. As you might imagine, to generate a model, we just type Rails generate model. Then we give it the name of the model. In this case, it's the singular, so user model. And then we're going to add the data model at the command line, and we're going to add the element of the model that Rails doesn't add automatically. So we're going to say user is, we're going to say name, which is a string. And email, which is also a string. Again, this might be familiar from lesson 2. One of the things that this Rails generate command creates is a so-called migration file. That's right here. It's got a timestamp. And the reason for the timestamp is because people found that different developers working on the same project would create migrations. And it used to be that they were numbered sequentially, and you'd have this problem that 2 migrations would have the same number. So there's a timestamp here to prevent that sort of clash. So let's take a look at that. So this is the migration file. So you can see that there's some inheritance here at the top. The create users class is inheriting from Active Record Migration. You don't have to know anything about this to use migrations. In this tutorial, we're never going to have to do very much with the migrations. We'll add a little bit, but not very much. And this migration in particular, we're not going to have to do anything to at all. But let's just take a look at the structure here. There's a method, create table. It takes 2 arguments. The first argument is a symbol, which is the name of the table that's going to be created in the database. And the second argument, which it might not look like an argument, but it is this block. So methods in Ruby can take blocks as arguments, as we've seen with things like each, and then in RSpec, describe and it. And here the block variable is t, which stands for table. Inside of the block, we have t.string name, Here's a name as a symbol. What this does is it creates a field for names, and also creates a field for email, and then it also creates timestamps, which are those magic columns I alluded to briefly before, created at and updated at. Now, it's important to emphasize that there's absolutely no reason for you to know the details of how this works. There's this T object, it's a table, you don't even really know exactly what it is. From the perspective of the day in, day out development of web applications, you're simply never going to have to know the details of how exactly this table object does its magic. So let's run this migration to create the table in the database. The command to do that is rake dbmigrate. Remember that if you haven't followed the advanced setup, you might have to use bundle exec rake dbmigrate at this point. There we go. Now, one common thing when running migrations is to realize that you made some sort of error in the initial data model, that maybe you forgot some element. And you'll want to undo the migration, make a change, and remigrate. So there's a way to roll back one migration, which is just to use rake db rollback. And this just inverts the migration. That got rid of the users table. Now, this is one nice feature of this change method. This method defines how to change the database. And in particular, what that means is that if we do rake db rollback, Rails knows how to invert this create table. So if you run rake dbmigrate, it adds a table and adds these two fields, adds these two columns to the table. And if you run rake db rollback, it just reverses that. Now, not all migrations are reversible, and if you do need to make an irreversible migration, you'll have to define two methods, an up method and a down method. All of the migrations in the Rails tutorial are fully reversible, but if you do find yourself in a situation where you need to make an irreversible migration, use the Rails guides at guides.rubyonrails.org and read the section in those guides on migrations. All right, let's go back and run our migration. Now, at this point, I'm talking about this system as if we have some sort of database already, and we're creating a table in that database with some columns. But you might be wondering, like, where is that database? And the answer is that by default in development, Rails uses a very lightweight database called SQLite. And one of the things that's really nice about SQLite is that its databases are just regular files. In particular, they're in the DB directory. So let's list that directory. And you can see here that we've got development.sqlite3. That file is what gets updated when we run rake dbmigrate. There's a really cool program called the SQLite database browser that's cross-platform. You can use your favorite search engine to find it and install it on your system. I've associated that program with SQLite 3 files on my system, and so I can use OS X's open command to take a look at it. It's actually really useful to know how to do this if you don't. So this is a quick aside for people using OS X. I'm going to open this directory. So what you do is you do like a control click or a right click, and you go down to, so you can say open with, and then SQLite database browser. You can see that it's the default. If you want to change that for all of the files with this file name extension, you go to get info, and then you select it here, and then click on change all. Of course, that didn't actually change anything on my system. So if you do that, then typing open and then the name of the database will open it in this browser. So we can see the results of the migration here. There are a couple of tables, schema migrations and SQLite sequence, that are used internally by Rails, and you'll pretty much never have to worry about those. But what we've got here is the users table that got created by the migration. And if we click on the arrow, we see that we've got an ID, name, email, and then created at and updated at. You can also see the types here, integer primary key. This is varchar, or some people say varchar 255, which is what Rails translates string into. And this sometimes will depend on the exact database used. So if you use MySQL or PostgreSQL, these might be different. I'm actually not sure offhand. One of the cool things about Rails is that it abstracts away a lot of the database internals, so you don't have to think about it. We can also browse the data here. Look at the users table, and you can see that, not surprisingly, it's currently empty. That's because we just created this. But you can see the columns. So the way that these structured query language databases, or SQL databases, are structured is we've got a table and then columns with data. So ID, name, email, created at, and updated at. Now let's take a look at the actual model file. It's in user.rb. You can see it's in app models, user.rb. So looking at the structure of this, we see that there's a user class that inherits from active record base. Now this class is defined by Rails, and it provides all kinds of useful functions for interacting with databases. There's a configuration file called database.yaml that tells Rails which databases to use in each environment. So the default environments supported by Rails are development, which is what we're doing now, test, which is what happens when the tests get run, and production, which is what happens on the production server. This actually gets ignored by Heroku. Heroku automatically uses the PostgreSQL database. And in fact, it's a good idea in general to use exactly the same database locally in development and for testing as you use in production. But all of the material in the Rails tutorial will actually work on both SQLite and on PostgreSQL. And configuring PostgreSQL is difficult enough that I think at this point, when you're just learning, it's a good idea just to use the default SQLite database because there's no configuration at all required. So what's cool about this file is that it means that you never have to think about how Rails is talking to the database. In particular, we're going to be using the various methods supplied by Active Record Base and some methods that we define ourselves to interact with the database in a way that never actually requires us to write any raw SQL. So the structured query language, or SQL, supported by SQL databases, is quite verbose, and it's really nice to be able to write Ruby instead of writing SQL. This line here says that the email and name attributes are accessible, which means that they can be set by what's called mass assignment. We'll be talking a lot more about this later in the tutorial, but for now you should know that any attribute that is editable through a web form should be in this list. And any attribute that is not editable, such as a parameter that indicates if a user is an administrative user, should not be on this list. It's also kind of weird that the email comes first. I'm going to change this around. We generated it in the opposite direction. Okay, there we go. Now, because we're making a data model here, we don't have any web pages yet to interact with it, and that's going to start in lesson 7. So you might wonder, how are we going to even investigate this user model? How are we going to learn how it works? And the answer is we're going to use the Rails console. Let's go to the command line. So I'm going to run Rails console, and I'm going to give it an extra flag here. I'm going to give it the option sandbox. This is a common idea in software development. The idea of a sandbox is to have a place to play where you can't do any damage. And so in particular, when you exit the Rails console when it's been in a sandbox, you can see that any modifications you make will be rolled back on exit. So actually, let's exit. You can see that it rolls back the transaction. What that means is everything you do gets undone when you leave the console, if it's in a sandbox. So let's load it up again. You may recall from lesson 4 that we were able to make our own user class, and we were able to create a new instance of that class using the new method. As you might imagine, the user model has the same property, so we can type user.new and see that created a new user with nil attributes. In the next lesson, we'll use a new user object as the base for creating a form that will then be used to actually create a new user. But of course, if you actually want to write a user to the database, it's going to have some attributes. So let's take a look at that. You might recall that we set up our custom user class to be able to take an initialization hash of attributes. And this is supplied automatically by Active Record Base, so we can do user.new and give it a name and an email. And now you can see from the output in the console that this user has a name and email address equal to the attributes that we passed. But you might also notice that the ID and the created and updated columns are nil. And that's because this object currently only exists in memory. In other words, it hasn't yet been saved to the database. The way to save a user object to the database is to call save on it. Let's call save. You might notice the output here includes the raw SQL that's used to insert the data into the database. I wouldn't worry about that too much right now, but you can learn a lot about how SQL works just by looking at this output. Now, it's possible that if you've done web development before, or if you've done a database administration, you already know a lot about this. It's certainly useful in the long run to know more about how SQL databases work, but for now, and indeed for most Rails application development, you can rely on Active Record to take care of the heavy lifting. Let's take a look at our user again. And now you can see that the user ID is no longer nil. In fact, it's just the number 1. And we see that the created at and updated at columns have automatically been given values. By the way, if you look at the time here, you'll see that it's 47 minutes after midnight. That's actually not the time right now where I am. This time is by default what's called UTC, which stands for Coordinated Universal Time. By the way, if you think about Coordinated Universal Time, you might realize that's not UTC at all. The letters come from a compromise. The standards committee in charge of this couldn't agree on using the word order from English or from French, so they compromised by using an acronym that doesn't correspond to any known language. Roughly speaking, UTC is Greenwich Mean Time, but that's not exactly right. And if you want to learn more about it, I'm sure that you can find it on the internet. Like the custom user class that we created at the end of lesson 4, this user object has attributes that can be accessed using the dot notation. So we can look at the name or the email address. We can also look at one of the magic columns. So we've seen here that you can first make a new user object in memory and then call save on it. There's a way to combine those two steps into one using the create method. You can see here that the user that's created by this command has ID 2 and has created and updated at columns set by the creation and update date. The created at and updated at columns are the same initially, and we'll see in a minute how to change the updated at column. The opposite of create is destroy. Let's create a new user. And now let's destroy it. I'd like to note that this email address is not valid. We'll be talking later on in this lesson about how to enforce a valid email address format. You also might wonder how we know for sure that we just destroyed this user. We can answer that by learning how to find user objects in the database. The simplest way to find a user is to use the find method. And we can pass it the ID of the user that we're looking for. So user.find1 returns the first user. By the way, you shouldn't rely on that fact. It is the first user in this case, but it doesn't actually return the first user. What it does is return the user with ID 1, which happens to be the same in this case. We can see that using the first method. This really does return the first user, and we can check that they're equal. In this particular case, so that's true. Of course, this won't be true if we happen to destroy the user with ID equal to 1. Now let's find the user that we just destroyed, or attempt to do so. It was the third user, which meant that the ID using SQLite is just 3. Let's find that. And what we get here is an active record not found exception. So this is a pretty noisy result in the sense that all we did was ask the database, hey, give me the user with ID 3. And instead of just saying, look, there isn't one, it gave us this error. And this is a convention in Active Record that says if you're passing an ID, you do so with the expectation that in fact that user exists. So under those circumstances, the user not existing is exceptional, which is why an exception gets raised. If you want to find the user by the ID and return nil if the user doesn't exist, you can use the find by ID method, and that just returns nil. Active Record automatically creates this kind of method, this find by ID. In fact, it creates one for all of the different attributes. So in particular, we can find by an email address, or by name, we won't use the latter in this tutorial, but this one here, the find by email, is exactly how we're going to find users in our application. As on many other websites, we'll be using the email address as the unique username. So we saw user.first. We can also do user.last. And there's one more really useful method, which is user.all, and this just returns all the users in the database. In this case, there are just 2. And as you might expect, user.all is just an array. One final common operation is updating the attributes of existing objects in the database. Let's take a look at our user object. Now let's change the email address. We can just assign to the email attribute That didn't actually change the user in the database, though. To do that, we have to save. Now, if we look at the user again, you can see that the updated column has been updated with a new time. Of course, the created column records when the user was created, and that should never change. There's a second way to update attributes using Active Record, and that's to use the update attributes method. And this just takes a hash. Say the name here is the dude, and the email address is dude@abides.org, because the dude abides. Now, if we look at the user, we can see that the created column is the same, but the updated column has been updated, and both the name and the email address are also updated. Unlike simple assignment, as you can see from the output here in the console, the update attributes method actually does write the changes directly to the database. As with the save method, and unlike the create method, update attributes returns true if the update succeeds and false otherwise. You may recall that the create method actually returns the object, which is why we were able to say foo equals user.create and then an argument hash. By the way, this update attributes is actually our second example of mass assignment. The first was when we called user.new and then gave it a hash of initial values. Let's take another quick look at the user model. The reason we're able to update the name and email attributes is because they're listed in this @accessible line. If when doing data modeling you find that you're mysteriously not able to update a particular column using update attributes, or to define it using user.new, it's almost certainly because you forgot to add it to this @accessible list. Now that we've gotten a basic idea about how to create and manipulate user objects, we're going to take the first step toward making an industrial strength user model by adding some validation to the data. When we created the foo user, we saw that we actually were able to create an email address that didn't correspond to an actual email format. In addition, if you experiment with creating new users, you'll see that right now we don't even have to have an email address or indeed a name. So in this section, we're going to fix that deficiency by adding some validations in the user model. Let's quit out of the console here. We can see that we've got that rollback transaction so that the database is now clear again. You can see that. If we browse the data here, we can see that there's no data currently in the users table. By the way, you may have heard that Rails uses the idea of convention over configuration. This is one example. We have a user model, which is singular here, and we've got a users table. It is possible to create tables that aren't plural like this, but Rails gives you a lot of functionality for free if you follow its conventions. We're going to start by writing some basic tests for users. Let's take a look at the current status of the user spec. This is the spec that was generated when we did Rails generate model. Let's run it. You can see that we've got here a pending spec. This just uses the pending method, which is sometimes useful if you want to put in your test file an indication of the kind of test you plan to write, but that you haven't written yet. You can also do this. If you have an it without a block, it'll just be a pending spec. But we're actually going to add some tests, so let's do that now. We're going to start with tests for the basic attributes that a user object responds to. The way we're going to do that is we're going to start with the before block, and we're going to create an instance variable in the test. You remember that in the context of a general Ruby class, an instance variable is available throughout the class. The same basic idea works inside of these specs. When we create an instance variable, it's available anywhere in the rest of this block. So in particular, anywhere in the describe block here. So we're going to create a user using user.new. And we're going to have a subject for this page. Remember, in the static pages spec, we have the subject as the page, and this page variable comes for free as part of the way we set up our testing. In this case, we want the subject to be the user. So we can just say subject at user. So now when we say it should have some property, it will automatically use at user under the hood. So just as a sanity check, we're going to make sure that this user variable has the right attributes. And in order to do that, we're going to use the respond to method. This just ensures that a user object actually has a name attribute and an email attribute. There's no distinction between attributes and methods, though, so this idea of responding is very general in the sense of message passing, which we talked about briefly in lesson 4. The idea is that if you call at user.name, then something will happen, that doesn't result in an error. And there's a way to test for that at the console. Let's take a look. Having just quit the console, we're going to fire it up again. We can say user.respond_to. We're going to call respond to with a question mark because it's a Boolean. So this returns true if this object responds to the name method or attribute. We can see that it does directly by calling user.name. Now our spec has a useful convention that whenever there's a Boolean method on an object, you can make this sort of construction. So it should respond to name, just transforms this code into a call to respond to with a question mark. So it's a very natural way of describing the attributes of a particular object, because this corresponds to the way we use these ideas in natural language. One of the things about test-driven development is that it's not always about getting test coverage for your project. Sometimes it's just a way of getting into the right kind of mental state to do development. And when you're doing data modeling, it's amazing how useful it is just to start specifying what the different attributes should be, especially when you do it in a test first way. Of course, we've already generated this name and email attribute, but as we add extra attributes throughout the rest of this tutorial, we'll always have a block here at the top saying it should respond to, and then the name of the attribute or method. It's a good way of getting over that barrier when you don't even know where to start. Another nice side effect of this is that at the top of our test file we have a big list of all of the things that users respond to. This is a useful way of documenting the characteristics of our model objects. So I said that we'd generated these name and email attributes, but if you run the test you'll see that they actually fail. You may wonder about that because, well, didn't we just spend a bunch of time at the command line inside of the console investigating these attributes? The answer is yes, but there's one step that we haven't made, which is that we have to prepare a test database, which will involve cloning the structure of the current development database over to a test database. The way to do that is with the rake task dbtestprepare. So no spaces, but with colons there, as you can see. So having done that, we can rerun our tests, and now they're passing. This is a very common source of errors, by the way. Sometimes the test database gets corrupted. Sometimes you'll just have forgotten to prepare it. But if you find that the tests are failing, especially if lots of tests are failing, when you think they should be passing, it's a good idea to try running rake dbtestprepare to see if that fixes the problem. Now let's start with our first validation. Ordinarily I would do this in a test-driven manner, but just at this stage, as we're getting to understand what validations are and how they work, I'm going to do the validation first, and then I'll show you a trick for turning this into a TDD step later on. So we're going to start with the idea of validating the presence of a name attribute. So the idea is that every user in our site has to supply some non-blank name. The way to do that is with the validates method. So we're going to say that this user model validates the name attribute, and the particular validation is that the presence should be true. So this name should be present. Let's see how that works. I'll keep exiting out of the console once you discover that we need to start it again. So we've added that validation, and now that we've started up a new console session, the console has loaded this new user model. So let's see how this works. We're going to say that the name is blank, and we'll give it an email address, just to show we don't have any validations on the email address. Well, let's just make it valid for now. Either way it would work because we haven't added the email format validation yet. So there's the user, and it looks like it worked, right? Because there's the name and the email address. But we can actually call user.save and see that it doesn't work. It's going to return false. Let's see here. And there's another method that you can use to find out if an object is valid from the perspective of active record. And it's just the valid question mark method. Applying the RSpec Boolean convention, that means that we can add a general sanity check on the subject of the test. We can just make sure that it's valid as follows. This is a second Boolean convention in RSpec. It should respond to name converts this to the Boolean, the question mark version of respond to under the hood. This, it should be valid, automatically calls the valid question mark method on the subject of the test. So let's run this. And so that's good, it's valid. And what this means is that if we were to change this, then we'd have a failing test there, and we would realize that there's something wrong with the subject of the test. But of course, this doesn't actually test the validation. In order to do that, we're going to make a new describe block. We're going to say when name is not present, and what we're going to do is have a before block that's going to say that the user's name is blank. And I'm actually going to put in a space here just to emphasize that it's actually not the empty string that's invalid. It's any blank value. You might recall in lesson 4 we talked about the blank question mark method. That's how this is implemented. I'm going to say it should not be valid. So what this does is that before the it block, the before block runs, and it makes the users name something that's not valid, and then the result should not be valid. If we run this test, we'll see that it's going to pass. There it goes. Now for a test as simple as this one, we can be pretty confident that this describe block here actually tests what we think it's testing. But if you do this a lot, if you make a habit out of writing your application code first and then writing the test, you'll discover, much to your surprise and confusion, that it's amazing how often the test doesn't actually cover what you think it covers. So in order to make sure that this test actually covers the validation, we're first going to comment this validation out, save it, rerun the test to make sure it breaks, and then we'll uncomment it, save it again, and verify that, in fact, that describe block that we just added with it should not be valid does test this validation. If you're ever in a situation where you have a bigger project that has lots of application code but no test coverage, this kind of technique is a useful way of adding tests incrementally and while being confident that you're covering what you think you're covering. Now let's add a similar test for email presence. Of course, in general, we want the email to have a specific format, but we definitely want it to be there. Those were escape completions, by the way. Just hit escape and it does an autocomplete. So let's run this. Should fail. It's good. And now we're going to say that the user model validates email. Present's true. Let's put a space in here just to line these up. It's not necessary, but it looks a little nicer. And let's rerun the test. And we see that we're passing. We're going to add one more relatively simple validation before tackling the more complicated validation of email format. We're going to enforce an upper limit on the size of the name field. So this will prevent users from putting huge names in. We'll just arbitrarily pick 50 as a reasonable upper bound on the length of a name. Our test will say that the user's name will be 51 characters long. And one easy way to do that is just to have a single character and then repeat it 51 times. Just recall that at the we can look at the console. A times 51 is just a string of A's 51 characters long. So we're going to set the name equal to that value that's too long, and then it should not be valid. Run the test, it should fail. And now we can say that the user model validates name, presence is true, and length has a maximum, this is also a hash, of 50. So this presence, this thing here is a hash, and the length key itself takes another hash as its value, in this case enforcing a maximum of 50. Remember that this hash doesn't need to have curly braces, but this nested hash does, just to avoid ambiguity. Let's save that and rerun it, and we should be green. And there we are. All right, let's move on to the format validation for email addresses. So in the test, we're going to build up a list of invalid email addresses, and then we're going to use the same idea that we're going to change the user's email address and then assert that it should not be valid. We're going to use the %w construction we saw in lesson 4, and we just remind you of how that works. We can do foo bar baz inside of %w, and that gives us an array of strings. So what we're going to do is something more like this. These are all valid email addresses. Remember that we can iterate through these addresses using the each method. we have a block here, and the block variable we'll just call address. Just put s the address, and we can see that it just prints out the addresses. Inside of the test, what we're going to do is iterate through them and have a test for each one of the steps in the iteration. All right, let's go back to our test here. And let's describe the user when the email format is invalid. So when the email format is invalid, it should be invalid, it meaning the user. So let's define our addresses. Now when it comes to email validations, I really think that the perfect is the enemy of the good, which means that we're not going to reject all invalid addresses, but we're going to reject the most common kinds of things you might see in a web submission. It actually is possible to build up a pattern that matches all email addresses, but it's such a pain. And in fact, it accepts lots of email addresses that most people wouldn't even consider valid. For example, Michael space Hartle at email addresses can technically contain spaces. So we're going to reject things that don't match the common kinds of email addresses that people have. So for example, this is a common error, using a comma instead of a period. We certainly need to have an @ sign, so let's have an email address that's missing one. And here's an example .user@foo. But then nothing after that. So we do need to have a top-level domain like .com or .org. Now for each of these addresses, we're going to change the user's email and then assert that the user is invalid. So let's do addresses. .each do. Just call the block variable invalid address just to emphasize that these addresses are invalid. So this user should not be valid. Let's run the test, and we should have a failing test. There we go. Now we're going to be using what are called regular expressions to build up a pattern to match email addresses. And such expressions are notoriously difficult to use. They can be quite brittle and error prone. So what we're going to do is also write some tests just as a safety net that match valid email addresses. And these addresses will be valid addresses. Let's just look at some valid addresses. So certainly user@foo.com is valid. We should be case insensitive. So all caps is also valid. JP is a valid top-level domain. And we can also have pluses, a plus b at baz.cn, say. So these are all valid email addresses. This doesn't cover all valid email addresses, of course, but this will match most of the common email addresses that people use. So let's do addresses. This is actually just, let's just copy this. And the only difference is this should be valid. And those will actually pass right now. Oops, it failed. This is why you run the test. So this should be valid address. There we go. So let's run the test again. Yeah. So all of this test here, this it block, is passing. So if this fails, it means that there's something wrong with the pattern we've used. By the way, it's a little inconvenient to have all of these tests in one it block, because technically this is only counting as one RSpec example, even though we're really checking multiple addresses. But this is the price we pay for checking a bunch of addresses at the same time. All right, so now that we've got some decent tests for email validations, let's talk about how we're actually going to do this. And in this context, I'm going to be using a remarkable web page called Rubular. Let's take a look at it. So as you can see here, Rubular is a Ruby regular expression editor. And one of the cool things about Rubular is that it's interactive. So we can have a test string here. In fact, let's put in some test strings from the console. Let's put these in. And actually, let's put in some invalid ones too. Just going to copy that and paste it in here, and then go up to here. This way I can just paste these guys in. And what you do at Rubular is you type in a pattern that matches certain strings and doesn't match other strings. And so you can figure out what kind of pattern you want to use by looking at this quick reference here. So regular expressions are a big subject, and I'm not going to have time to cover everything about them. But you can get surprisingly far just by reading over this quick reference and experimenting with things. So let's think about the kind of email addresses that we want to match. We've got a good list of examples here. Well, we want to start at the start of the string. So we're going to use the \a right here. And then we'll use \z for the end of the string. So capital A and lowercase c. So \a, \z. And what's going to go in here? Well, an email address should have an @ sign. And then it should have like word characters of some kind. So you can see that \w matches any word character here. It's a letter, number, or underscore. Let's take a look at this. And up you can see from the quick reference that a plus sign matches matches one or more of a. So \w matches one or more of a word character. And the reason it has to be one or more is that 0 or more isn't enough. If we did \w star, that would match 0 or more, but that matches too many things because we have to have something before the @ sign. And now let's just put another \w plus, say, .com. Now, this is a little tricky because you can see here that the dot character is used to match any single character. So to match a literal dot, which is what you'd have in a .com, we need to escape it with a \. So this is \dot. So I put the \a and the \c in here, and that's going to be useful for the actual regular expression that we use inside of the user model. But in this case, our test string is actually a bunch of email addresses. So what we want to do is remove these here. There's no way we're going to match this string because the beginning of the string is up here in front before user@foo.com, and the end is here at the end of example.user@foo. So for the purposes of illustration, I'm going to remove these, but we are going to be using \a and \c in the real regular expression. So let's undo those. And so now you can see that we actually are matching some things. So have it like a .com. So if we have \w at \w plus at \w plus \.com, that's matching user@foo.com. So this is a really useful result. We've now matched one of our valid test strings. And so by experimenting with this regular expression quick reference and the interactive Rubular editor, we can build up a regular expression that matches the various email addresses here in our test string and doesn't match the ones that we don't want to match. So in particular, we want to match these guys, these three here, but not these three. So I'm going to skip a little bit ahead and put in the full regular expression. You shouldn't take this regular expression as gospel. This is an expression that has served me well in my web development, but it could be that you'll find that it doesn't quite match what you expect. Maybe there are a few valid characters that your users use. But the chances are that this regular expression is good enough for almost all uses. So if you look down here in Rubular, you can see that there's a way of matching any single character of A, B, or C using square brackets. So what we're going to do is match not just word characters for the stuff before the @ sign, but we're going to match a hyphen and we're also going to match a dot. So you can have something like first dot last. Notice we actually haven't matched a hyphen here. That's probably a worthy thing to add. Let's add that to our test. Let's just put a hyphen in here. All right, so now we want to build up a list of several possibilities. So let's take a look at this. We've got a word or a hyphen. Now it turns out that inside of these square brackets, the hyphen has a special meaning. And so you can see that A through Z, for example, matches any single character in the range from A to Z. So that means in order to match a literal hyphen, we have to escape it out. Remember, the way you escape something out is with the backslash. And now this is a little tricky because inside of these square brackets, the dot character does not have its special meaning. And this is where regular expressions can get a little tricky, and it's worth reading about them a little more after you finish this tutorial. So this is the kind of thing that you learn with experience. So inside of these square brackets, a dot doesn't have any special meaning, so we don't have to escape it with a backslash. So this section here, this stuff in here, matches any combination of word characters, that is to say letters and numbers and underscores, along with a hyphen and a literal period. And so what we want is one or more of those characters. So that's the plus sign. Or this is A plus, where A is this whole thing in square brackets. So we're going to put a plus, and we should match, at the very least, we should match user@foo.com. Maybe something else. Okay, so only user@foo.com is matched by this regular expression. So let's look at the stuff after the @ sign. So one of the things we want after the @ sign is that we want at least one letter, digit, hyphen, or dot before the top level domain here, like .com. So that's going to be a letter, a hyphen, or a dot. Now by including this dot here, we've automatically taken into account the possibility of a compound domain like foo.bar.org. So this thing here will match the foo.bar stuff. In fact, we can put a .org here just to show that. You can see, so this now matches the _us-er at foo.bar.org. So all we have left to do is match this top-level domain. Now, of course, there is a list of valid top-level domains, but what we're trying to do here is to catch obvious errors. We're not trying to catch everything. So what we're going to do is allow a top-level domain that consists of at least one letter. Now, all current top-level domains are at least 2 letters long, but we are not losing very much by only requiring 1 letter, because what we're really trying to do here is to catch typos. So for the purposes of the tutorial, it's fine just to match any single character of A, B, or C. So let's do that. Or actually, what we really want is any single character in the range A through Z. So let's do that here. And we want at least one of them. So 1 or more. And so there we go. You can see that we're now matching all 3 of the valid email addresses, and we're not matching any of the invalid ones. By the way, if it makes you uncomfortable, this idea of matching 1 letter top-level domains, you can just do something like this. You can just replace this plus sign with 2, comma, close curly brace. If you were to do that, then you might want to alter this, because right now we have something like foo@-.jp. You can see that that is matched as a valid email address too. So as I mentioned before, in this case I think the perfect is the enemy of the good. So we're just going to stick with the simpler regular expression, which is this one. There's actually one minor thing we're missing here, and in fact let's write a test for it. Email addresses are truly case insensitive, so something with a capital COM ought to be valid. Let's try that out here. So you can see now it broke our match. So what we want is a case-insensitive comparison. And there's a way to do that. If you look down here, there are some options. I for case insensitive, M is to make dot match new lines. Ordinarily, this dot character doesn't match the \n characters. X ignores white space. This is actually useful if you want to build up a regular expression in multiple lines. X is a useful thing to do for that. And then, actually, I don't think I've ever used this one. But the other three I've definitely used. And we're going to use the case-insensitive one right here. And you can see now we're matching our result. So before we actually put this into the user model, I want to show you how to use this at the command line. So I'm going to copy this. All right, so I'm going to try to do a comparison between a valid email address and the regular expression. So the way you do a comparison in Ruby between a string and a regular expression is with the equals tilde operator. If you've ever done any Perl programming, this will look very familiar. This syntax is taken right from Perl. So I'm going to paste this in and put in the slash. So if you look at Ruby, you can see that there's a slash here and another slash here. That's because that's what you use to denote the regular expression. And then we're going to put a slash I here. And since now we're doing one string at a time, we can do this \a for the beginning of the string and \z for the end of the string. Remember, that's from right down here. These guys here. So if I hit return, we should have a match. The number 0 is what appears. This might be confusing to you, but remember that 0 is true in Ruby. So we can coerce this into a Boolean context by putting a bang bang and make it true. Let's put in an invalid email address, example, nil, which is false in a Boolean context, and that's what we want. Now, part of the reason I showed you this is because this is the syntax you'll see in an ordinary Ruby program for regular expression comparisons. We're not going to use that in the user model, but this is a very useful syntax to know about. In fact, we've already used it in the last lesson. Recall that there's a helper spec. This is how we did the full title test in the last lesson. At this point now you can recognize that equals tilde foo just matches the pattern foo. Right, at this point we're ready to actually do the validation. The way to validate the format of a particular attribute is just to use the format key here, format, and then format expects a regular expression. So we're going to say with, and then we're going to give it a regular expression. And in fact, it's going to be long enough. Actually, we know what the regular expression is. This regular expression is long enough that we want to make a constant for it. So let's just do this here. Remember, constants start with capital letters. This is a common abbreviation for a regular expression, usually pronounced regex. And it's going to be equal to this slash, and then here's the regular expression. Remember, we want the beginning of this, the string, then that stuff, and then the end of the string. And we want it to be case insensitive. So that should be it. Let's run these tests. See if it works. Look at that. 8 examples, 0 failures. We can see the value of this second set of tests by getting rid of the case insensitivity here and rerunning them. Now it actually fails. That's because of the capital com here. But with the I there, it should work. And now our application will reject most common invalid email addresses and will accept most common valid ones. We're ready now to implement the final validation for email addresses, which is to require them to be unique in the database. The reason for this is that we're going to be using email addresses as a unique username. So duplicates would cause there to be two accounts associated with the same person. The initial implementation of this is extremely easy, but unfortunately it doesn't quite work. And as we'll see, actually having an industrial strength uniqueness validation will take quite a lot more work. But in keeping with the philosophy of the sample application, where everything we do for real, I'm going to show you how to do it, even though it gets a little bit advanced. Let's write a test. We can describe when email address is already taken. So what should happen when the email address is already taken is that a new user should not be valid. There are several ways to do this. The way we're going to do it is to put a before block and actually save a user with the same email address as the subject, as @user. So before, we're going to make a user with the same email address. And we can actually use user.new and just pass it in the same email address. But there's a slicker way to do this with the dupe method. This just makes a duplicate of the user. So if we do user with same email.save, this saves a user with this email address, with user@example.com. In this case, it should not be valid. Let's save that and run the test here. And as required, we have a failing test. So the first cut implementation is extremely simple. We just have an extra field called uniqueness and say that that's true. So this now enforces uniqueness. So if we try to create a new user, it won't actually go through if the email address already exists in the database. This isn't quite good enough though, because if you think about it, the email addresses are not case sensitive. So to test for that, let's upcase the email. So user with same email.email equals @user dot email dot upcase. You might recall that upcase returns the uppercase version of a string. Rails has a way of handling this case too, which is to pass, instead of true for uniqueness, you can just pass an argument, a hash, which is with the key case sensitive, false. And it knows that if there's something here that this means uniqueness is true, but with no case sensitivity. So we can save that and run it, and now we've got a passing test again. So the problem is that this doesn't actually work in general. And the reason is because of what's called a race condition. So there's a scenario where one user, say named Alice, signs up to the sample application with her email address, and then she clicks on submit twice, which sends two requests in quick succession. So what can happen is the first request will create a user in memory that passes validation, and the second request does the same, and then both of them get saved in quick succession. And the result is that two user records with the same email address get created despite this validation. It's still useful to have the validation, as we'll see. Not only does this prevent a lot of the common duplication cases, but it also generates a nice error message for us to use in the view. But in order to prevent this condition where we have duplicate email addresses in the database, we need to do something at the database level as well. By the way, in case this scenario sounds implausible, it's not. The way I learned about this scenario was that it actually happened to me in one of the websites I ran. So I wish this were just theoretical, but in fact it's not. So the way we're going to do it is we're going to add an extra piece of structure to the database that enforces uniqueness at the database level as well. so that if we try to save a user with the same email address that already exists, it will raise an error. Unfortunately, I actually don't know how to write a test for this, because inside of Rails it's very difficult to replicate that condition, that scenario that I mentioned. The method we're going to be using is called an index. So let's generate a migration to change the database. We're going to add index to user's email. And let's take a look at that migration. So you can see in this case, since we didn't generate a model with the attributes on the command line, but rather just use Rails generate migration to make a generic migration, we actually don't have anything inside the change method, so we have to add it ourselves. And the way we're going to do this is add index to the users table. So here we're using the add index method that comes as part of the active record migrations. So we need to give it the name of the table, the column, which in this case is email, and then we want to tell it unique is true. Save that. By the way, this solves a second problem. Later on in the application, we're going to be retrieving users from the database using their email addresses. Now, if you think about it, in general, what that means is that you would have to look through all of the records in the database and compare the email address of each user with the submitted email address one by one in order to find a match. So if someone were trying to sign into the website with an email address that didn't exist at all, it would actually have to go through all of the records in the database. This kind of process is known as a full table scan, because it has to scan the entire users table in this case. And this is generally a really bad thing, because as the number of users grows, the full table scan gets longer and longer. If you think about it, this is analogous to having a problem where you need to find a particular word in a book. So suppose you had a book that contained an email address in it somewhere. In order to find that email address, you would have to page through the entire book, looking at each page, trying to find that email address. Of course, for an ebook, you can just search it electronically, but for a print book, you don't have that option. And in order to avoid going from page to page, there's a time-tested solution called an index, which is to accumulate a list of all of the page numbers where a particular string appears. So a database index is just the same thing, except in the context of a database instead of a book. So what this index does is it makes lookup by email very fast. So by enforcing uniqueness at the database level using unique true, we get a nice dividend, which is that later on when we find users by their email addresses, that lookup will be efficient. Let's close this down and run the migration. By the way, there's a file called schema.rb that has the structure of the database. And so if you open it up, you can see that we actually did just add something to schema.rb. That's what running that migration did, basically. Now, unfortunately, even this solution isn't complete. And I used to think it was, but several readers pointed out that, in fact, this uniqueness at the database level also is case insensitive. So that means that since email addresses are case insensitive, we have to ensure that the case is consistent in the database. And I really don't like having to introduce something this advanced so early, but this kind of problem is such a disaster if it actually happens in production that I feel like it's an important thing to raise even at this early stage. So what we're going to do is use what's called a before save callback. So this is something that Active Record supports. And we'll see another example of this later in the tutorial. But this is our first time encountering the idea of a callback. So what a callback does is that it executes a particular piece of code at a particular time in the life cycle of an active record object. So before save, we'll execute the code in this block that I'm about to define before an object is saved. So this block takes a single block variable. There's actually a slightly slicker way to do this, but at this stage this is the clearest way. So we're going to define a block variable corresponding to the user. And we're going to force this email address to be downcased. So this is the opposite of the upcase method. So what this means is that all of the email addresses in the database will be lowercase, which means that if you actually do save a user with an identical email address, it will raise an error. So let's save this, and we can actually take a look at this. So let's get rid of this validation here. This has broken our test, of course, but what we're going to do is go to the console and see how this works. Oh, and actually, there's an obvious mistake here. So if we run our test, we can see that there's a problem. Let's uncomment this. Let's run these tests. You can see that there's actually going to be errors. You can see undefined method downcase. It's because this shouldn't be user.downcase. This is user.email.downcase. You might have caught that. I didn't. All right, now let's comment this guy out and open the Rails console. So let's make another user with the same email address, and let's do it all uppercase. Different name, but same email address. See if that user is valid. It should be, remember, because we got rid of that validation. So the user is valid. See what happens if we save it. There we go. So what we got here is an error. This is active record statement invalid. So what we got is an exception, SQLite 3 constraint exception. And that's because of the database index that we just added. So we can see here directly at the command line that, in fact, we now are protected against duplicate email addresses. But as I mentioned before, I actually don't know how to do this inside an automated test, so we're going to keep this by hand and be satisfied that we've got that working. And we're just going to restore this so that our tests pass again. There we go. At this point, we're done with the validations for name and email address, and we're ready to add the final of the initial attributes for a user. We'll be adding more attributes in later lessons, but with this next edition, we'll have an industrial strength user model with name, unique email, and as we'll see, an encrypted password that we'll be able to use to authenticate users on our site. Let's take a look at what the new updated users table will look like. We see here the same columns we saw before in the users table, ID, name, and email, and then created at and updated at, which are the magic columns. I've kept them at the bottom to emphasize that they're special. And then we've added this password digest column. It turns out this name is special. If you have a password digest in one of your models, you can use a special method called hasSecurePassword provided by Rails as of Rails 3.1. Under the hood, the hasSecurePassword method that we're going to be using uses the bcrypt library, which is an industrial strength cryptographic hash function in order to do the hashing of the password. In order to use it, you'll have to add bcryptruby to your gem file. This is part of the Rails tutorial gem file that I've mentioned before. Remember, it's at bit.ly/Rails tutorial gem file. So if you followed that step, you've already got bcryptruby installed on your system, which means that we're ready to go. In keeping with the theme of having tests for the different attributes, let's add one for the password digest. Save that and run it. It should fail. And now let's generate a migration to add that column to the users table. This is a special name. We're saying add, then the name of the column, and then the name of the table, add password digest to users, and then the name of the column, again, password digest, and its type. So you'll see that this actually does something pretty clever. Let's look at the migration. Here's add password digest to users, and you can see that Rails used the name of the migration and the information at the command line with the type of of the column to synthesize a change method, add column users password digest string. So this is the name of the table, this is the name of the column, and this is the type. So we actually don't have to do anything with this. It's already ready to go. Just have to run it. And let's run our test. Nope, still failing. So this is the kind of thing where this will happen. Even to me it happened. So what happened here is that I, and by extension we, forgot to prepare the test database. So this should be your go-to answer if you're doing something with the database and the tests are failing when you think they should be passing. It's almost always rake db test prepare that has to be run. Right, now let's take a look at this. And good, now it's passing. All right, so at this point we're ready to write some tests for passwords and their confirmation, and also some tests for user authentication. Now, this is going to be pretty heavy going. There's lots of testing here. And this is the kind of thing that if you haven't done a lot of test-driven development, it might look a little scary. But with experience, you'll be able to write a full specification of what the code ought to do in the test file before even writing any of the implementation code. So if you find the following code straightforward, that's a really good sign. But if it doesn't seem straightforward, that's also okay. What you should understand, though, is that we're placing fairly sharp constraints on the behavior of our application. And so after writing these tests, we can be confident then when they pass that the implementation code actually does what we want it to do. Let's take another quick look at our mock-up for the sign-up page. So this is a typical sign-up form on the web. There's a name field and email field, which we've already taken care of. And then there's a password and the password confirmation. You might suspect that our user model is going to have a password and a password confirmation field, and your suspicion would be correct. So let's put that in our expectations here. It turns out you do have to have password underscore confirmation in order to use the has secure password method that we'll talk about in just a few minutes. You wouldn't necessarily be able to guess that just from looking at the mock-up. There's something else worth noting, which is that the way has secure password works is that it creates these attributes on the fly in memory. They do not correspond to columns in the database. In fact, let's take a quick look at has secure password just to see where we're going. Here's the source code for has secure password up on GitHub. And you can see it's actually got quite a lot of documentation. This is a big documentation string. It's commented out. Then here's the actual has secure password method. You can see that it requires bcrypt. And there's an attr reader. Remember we had attr accessor for the custom user class in lesson 4. Attr reader just creates an attribute that can be read from but not written to. You can also see that it's got a validates confirmation of password. This is actually an old style validation, but it still works. The newer style validations use the validates method, and then it would say confirmation true. But underneath the hood, this synthesizes a password underscore confirmation attribute in much the same way that this synthesizes a password attribute. I'm actually not sure exactly how it does it, but that's okay. We've specified here what the behavior is, and we don't actually have to worry about the underlying implementation. All right, before proceeding, we actually need to make sure that this user is valid, and since now we're requiring a password and a password confirmation, let's put those expectations in here. Password is foobar, and password confirmation is going to be the same. All right, it's a little bit too long now, and so you can see here we've spilled into column 83, and I don't like doing that, so let's just make this a do end block. Gives us a little bit more room to play with. Remember, this is just the same. There's actually a really subtle difference between do end and the curly braces, but it's not ever going to affect us in this tutorial. In fact, it's so subtle I don't remember exactly what it is. There's some sort of precedence difference between the two. Okay, so there we've got our before block. Now let's write a validation for the presence of a password. Now we're going to be enforcing the agreement of the password and the password confirmation. And so for this test, where we're going to be making sure that the password is present, we're also going to make sure that the password confirmation matches the password at the same time. That way we don't invoke the password mismatch confirmation that we're about to implement. Describe when password is not present. So before, we're going to say at user.password equals at user.password confirmation equals a blank. I'll just use a space to emphasize that it doesn't have to be empty. And then it should not be valid. Notice that we can chain these assignments here. A equals B equals 1. We can just do that here. So we've assigned both password and password confirmation in this one line. So what are the other requirements of these passwords? Well, the password has to match the confirmation. So here the password confirmation is going to be a mismatch. So we'll just do mismatch. It could be anything that isn't foobar, but this expresses our intent. Should not be valid in this case. You can see that this pretty much parallels the previous stuff we've done with the other validations. There's one more annoying thing that we have to deal with. Unfortunately, the validations don't work when the password confirmation is nil. Now, this will never happen when someone submits something through the web. But if you were to do something like this once the validations are implemented, if you were to do password foobar, if you were to do password confirmation nil, this actually wouldn't run the confirmation. So even with the confirmation enforced, this would not work. So to take care of that possibility, let's add one more validation here, or one more test. Describe By the way, I didn't think of this. Okay, when I was first writing these tests, I totally missed this, and some reader commented that, in fact, it was necessary to test for the password confirmation being nil. So if you look at this and think, wow, I would never have thought of that, I didn't think of it either. This is one of the reasons it's nice to make your software open source, is people will catch stuff like this. All right, let's save this and run our tests to see where we are. All right, we've got a bunch of failing tests. In fact, all of them are failing. Let's see what the problem is. You see we've got an error here. We've got an exception, active model mass assignment security error. Remember, mass assignment is the practice of using a hash like this to initialize or modify the content of an object. And so in this case, what's happening is that name and email are accessible, but the password and password confirmation aren't. So let's add them to the list. We run our tests. Still 15 failures, but it's a different error. Now we have an unknown attribute error here. That's because we don't know about the password. And in fact, that's true. Password is added by hasSecurePassword. So let's just implement this now. Rerun our tests. Now we've only got 2 failures. The first is the password presence validation, so let's add that. We can do that in analogy with the name validation. And the only thing left is this problem with a nil password confirmation. And we can fix that by putting in a validation for the password confirmation presence. All right, there's one more elementary validation I want to add. I want to add a validation for the length of the password. It's a good idea to enforce a minimum length on this. And let's decide that we want password to be at least 6 characters long. So let's just have the letter A repeated 5 times. That'll be too short. In this case, it should not be valid. Let's run our test. It should be red. And you can probably guess this based on the length maximum 50 here. In fact, let's just copy it. Instead of length maximum 50, we want length minimum 6. Let's rerun it, and we should be green. Excellent. All right, now we're ready to start building the authentication machinery. Let's get a sense of how we're going to do this. I'm just going to type some things at the command line. I don't actually want to create a user here. I'm just going to Control-C out of that. So later on in the tutorial, the way we're going to retrieve users from the database is like this. So we're going to have some email address, and we're going to use find by email. I'm going to assign that to a user variable. Of course, this isn't going to work right now, but I'm just going to hit return and pretend like we have a valid user. And the way we're going to identify the current logged in user of our application is using a variable called current user, with an underscore. And what we're going to do is we're going to have a user that we find, and then we're going to say user.authenticate, and we're going to pass in the password. So what this authenticate method will do is it will return the user if the password matches the user's encrypted password in the database. So this authenticate method is supplied by hasSecurePassword, which means all we need to do is write some good tests for it, and then use hasSecurePassword to get them to pass. So our first step, as you might be able to guess, is to comment hasSecurePassword out. We needed it to get the password test to pass, but now we don't want it there because we want this to be truly test-driven. So let's run our tests and make sure they fail. Good. So now we want to describe this authenticate method. What do we want it to do? Well, there's one thing we want to do initially, which is to add a requirement here. Remember, this isn't strictly necessary, but it's nice to document that users have an authenticate method attached to them. This next step is a little bit advanced. So if you find this confusing, I recommend watching this a couple times and maybe reading over the section in the Rails tutorial book a couple times, because there's a lot going on here, but if you break it down, it's not too complicated. In order to get this section to work, we're actually going to have a user in the database. Everything so far has been using user.new, which just puts the user in memory. But now we actually need a user in the database, so what we're going to do is before we do anything else, we're going to save that user. And now we're going to pull that same user out of the database, and we're going to assign it to a local variable called foundUser using the rspec method let. So let takes a symbol, which is the name of the variable we want to create. We're going to call it foundUser for the user that's found in the database. And now we're going to use this find by email method. So we're going to find the user by email, and it's just going to be @user_email. So there are two possible cases for the authenticate method. One is if the password that's passed in is valid. So let's describe that. when the password is valid, the return value of authenticate should be the user itself. If you look back at the way we were using it here, current user equals user.authenticate password, this should return the user into current user so that it can be assigned to current user. So this design is just the way that HasSecure Password works. If you don't like this design, then you can feel free to roll your own authentication system without HasSecure Password. But this is the design of the HasSecure Password method. So in this case, it, meaning the subject, which is @user, it should be identical to found user dot authenticate, and then the password of the user. So this is the sequence. We find the user using the email address, then we call authenticate on that user, and what that should do is give us the original user if the password is valid. And if the password is invalid, it should not equal the user. You can just do the same thing here. It should not equal found user.authenticate, and then some invalid password. Let's just pass it the word invalid. There's one more aspect of this that we want to test, which is just something you'd have to know about the HasSecure Password implementation, which is that when the submitted password is not the same as the user's password, this should return false. In order to test that, we actually want to bind this found user to a variable just for convenience. So we're going to use let again. And let's describe what this is. This is the user for invalid password. So here it is, should not equal user for invalid password. That was escape. It's really nice. You can define long things like this and just use escape for autocomplete. And then we want to say that it should be false, that this user for invalid password should be false. But remember, the subject of our test is @user. So what we want to do here is specify a property of something other than the subject. And the way you do that is with a specify method. So we can specify user for invalid password should be false. Now, in principle, these tests are unnecessary in the sense that HasSecure Password is used by lots of people, and we can be confident that it works. The main reason why it's nice to write these tests is because this is a specification for the behavior of HasSecure Password. So while this is a lot of work and it might seem a little mysterious, this should make the behavior of HasSecure Password seem a little less magical, because even though we don't know exactly how it's doing what it does, we do know what its actual behavior is, because we've specified it quite precisely here as RSpec tests. Alright, so this is all the machinery we need to have an authentication system for our application. Let's run our tests to verify that we're currently read. And everything is read because the password attribute doesn't exist. Right? Remember, unknown attribute error. So let's uncomment this HasSecure Password, run our test again. And there we go. Look at that. With that one line, we got everything to pass. Now, I showed you the source code before. Let's take another look at it. If you want to learn more about how HasSecure Password works, I recommend digging into this source code and just taking a look at it. As you might imagine, it's fairly advanced, but it's well documented, and you can learn a lot about Ruby and Rails by studying it. This completes our basic user model, so as a capstone to this, let's actually create a user in the database. Let's double check that the console is started not in a sandbox. You can see that there are no users by using user.count. And now let's create a user. Use the create method, and then let's just name this user after me. Let's see what happens here. There we go. We can see down here that there in fact is a user in the database. Got created at and updated at columns, and we've got this password digest, which is this long crazy string. That's what bcrypt creates. So what's going on is that we have all these validations run, and then under the hood, HasSecurePassword converts the password into this encrypted version. And later on, when we pull the user out of the database, what we're going to be able to do is say, okay, is the submitted password, when encrypted, equal to the password digest? So what's cool about this is that because the password is encrypted, even if someone were able to get a hold of our database, they wouldn't be able to get the user's passwords, because this encryption is extremely difficult to reverse. There's the full password digest string. And if you know anything about this sort of encryption, bcrypt includes what's called a salt as part of the encrypted password. So at this point, we can actually see how the authenticate method works. Let's pull the user out of the database again and just assign it to a variable. Oops. There we go. So here's the user variable. And now, let's authenticate with an incorrect password. Is invalid. That returns false as required. And user.authenticate foobar should return the user. So later on in the application, this is the basic method we'll use to allow users to sign in to the site. As a final step, let's take a quick look at the actual database. It's always gratifying to see things actually work. Let's look at the users table. And you can see here that there in fact is a row here in the users table, ID1, name, email, created at, updated at, and password digest. Let's add all the changes we've just made to Git. And we can merge it in to the master branch. And let's run our test suite. So this is an industrial strength user model that we've made here, suitable for deployment to real sites. In the next lesson, we'll learn how to make a working sign-up form that stores user information using this user model. And in the lesson after that, we'll use the authentication machinery we've just built to allow users to sign in to the website. We've covered a lot of material here, and so one thing you might want to do at this point is learn how to use the Rails API. So before ending, let me just show you that. Learning to use the Rails API is a very valuable skill, so let's pick one of the things. Let's look at validates here and type it in. So here's the validates method. If we look at it, we can see here in the documentation that it tells us all kinds of things that we can do. We can, here's the confirmation validation. We've got the length validation. So you can read about the different things that the Rails validations can do. Anytime you get confused about something in Rails, I recommend taking a look at the API. One final useful source is the Rails guides. Let's take a look at that. We use this before save callback. So let's take a look at the callbacks here. So here's the section in the Rails guides on active record validations and callbacks. You can use this to learn a lot about the object lifecycle and active record and the different kinds of callbacks that you can use to modify the behavior of active record objects. This is a short addendum to correct a minor error in the main screencast. This regular expression here actually matches a little bit too much. I just copied this part from the valid email regular expression and put it in here. But in fact, this matches both a literal plus and through the \w, it matches an underscore. And neither of those is valid in a domain name. So let's go to Rubyler. You can just paste this in. Here we go. And you can see that with the case insensitivity here, this matches all of these valid email addresses. I actually forgot this a plus b at baz.cn before. But you can see that that matches. The problem is that we're matching too much, though, so let's put in a couple things that should be invalid here at the bottom. Let's do foo at bar underscore baz.com. You can see that it's matched here on the right, but it shouldn't be matched. Foo at bar plus baz.com also matches, but we don't want it to match. So we can get this to work by replacing this \w with A through Z. And remember, the issue is that we want to match letters and numbers, but not underscores. So we can put A through Z and then \D for digit. If you scroll down here, you can see that \D is any digit. And so now we've fixed this problem. Now we're not matching the one with an underscore here. And all we need to do now is get rid of the plus, and the last erroneous match is gone. So this is the final regular expression. Before we proceed, let's make sure to catch this in the future if we have any regressions by writing a test. So let's copy these guys, put them in here. Actually, these are invalid. Let's run our tests, and they should be failing at this point. That's right. And so now let's replace this here. Just paste this guy in here. Copy it and paste it in. And now we rerun the tests, and it should be passing. Excellent.